A bit is the smallest unit of data that a computer can store. A bit can have only two possible values. It can be 0, which represents OFF, or it can be 1, which represents ON. Think of it like a simple light switch.
The switch is either off or on. There is nothing in between. In the same way, a computer stores information using only 0 and 1. Every piece of digital data, from text to images and videos, is built using these two simple values. 1 bit can represent only two possible values. These values are 0 and 1. But what happens if we add another bit? With 2 bits, the number of possible combinations doubles. Now we can represent 4 different values.
They are 00, 01, 10, and 11. If we add one more bit, we now have 3 bits. 3 bits can represent 8 different values. Notice the pattern. Every time we add one extra bit, the total number of possible combinations doubles. This simple idea allows computers to represent larger numbers and store more complex information using groups of bits.
Now let's learn about a nibble. A nibble is a group of 4 bits. Instead of working with individual bits, computers often group 4 bits together to represent more information. A nibble can create 16 different combinations. These combinations range from 0000 to 1111.
In computing, each nibble is represented by one hexadecimal digit. For example, the binary value 1010 is written as the hexadecimal digit A. Using hexadecimal makes long binary numbers much shorter and much easier for people to read. You will learn more about hexadecimal numbers later in this course. Now let's move on to the byte. A byte is made up of 8 bits grouped together. Unlike a single bit or a nibble, a byte can represent much more information. With 8 bits, a byte can store 256 different values. This is because 2 raised to the power of 8 equals 256. A single byte is commonly used to store one character, such as a letter, number, or symbol. For example, the letter A is stored using the binary pattern 0100000001 in the ASCII character set. This is why text files are measured in bytes. Every word, sentence, and document on your computer is simply a collection of many bytes working together. Now let's look at the word size of a processor. A word is the amount of data that a CPU can process in a single operation. Unlike a byte, a word does not have a fixed size. Its size depends on the processor's architecture. Older computers commonly used 16-bit processors. A 16-bit processor can process 2 bytes of data at one time. Later, 32-bit processors became the standard. They can process 4 bytes of data in a single operation. Today, most modern computers use 64-bit processors. A 64-bit processor can process 8 bytes of data at once. A larger word size allows the CPU to process more data in each operation. This improves performance, supports larger numbers, and enables the computer to access much more memory. That is why 64-bit processors are used in almost all modern computers today. Now let's look at how digital storage is measured. Computers can store enormous amounts of data. To make these sizes easier to understand, we use larger storage units. We begin with 1 byte, which contains 8 bits. When we combine 1024 bytes, we get 1 kilobyte, or KB. Next, 1024 kilobytes make 1 megabyte, or MB. Then, 1024 megabytes become 1 gigabyte, or GB. Finally, 1024 gigabytes make 1 terabyte, or TB. Notice that each storage unit is 1024 times larger than the previous one. This is because computers work using binary, which is based on powers of 2. That is why you can also see these units written as 2 to the power of 10, 2 to the power of 20, 2 to the power of 30, and 2 to the power of 40. As we move from bytes to terabytes, the amount of data we can store increases dramatically. These are the storage units you will see when using computers, smartphones, USB drives, and hard disks every day. Now let's compare the sizes of different types of digital data that we use every day. A single letter, such as A, usually requires just 1 byte of storage. A page of text is much larger and typically uses around 4 kilobytes, or 4 kilobytes. A high-quality photograph usually takes about 5 megabytes, or 5 megabytes. An MP3 music file is often around 7 megabytes, depending on its quality and length. A high-definition video can easily require around 4 gigabytes, or even more. Modern video games are much larger, often taking around 100 gigabytes of storage. Many laptops today include a 512 gigabyte solid-state drive, giving plenty of space for files and applications. For even more storage, external hard drives commonly provide around 2 terabytes of capacity. As you can see, different types of files require very different amounts of storage. Understanding these storage units helps you choose the right device and estimate how much space your files will need.